Today I'm going to be putting together a couple of communicators, well, probably over the next couple of days. And these are devices that can do texting and communication over different radio frequencies. And I have together most of I think all the pieces that are required, including the different some PCB boards, batteries, Arduinos, breakouts. Most of the stuff I bought from Adafruit or Amazon. I'm trying to do it with stuff you can buy just over the internet pretty easily. Mostly from Amazon. Actually, you probably could get all of it from Amazon. So it does take a while to build, and so what I do is break it up into a few different pieces. The first, what I would call the base, has the Arduino on it. It's got power management underneath, real-time clock, and then some connectors for the pins from other layers to connect into. So this will be the base. This is what I'll build first. And once I've built a couple of these, and I'll probably do some quick tests and make sure these different breakouts are working. Then the second layer has the connector to the display, and some routing to connect both of these top breakouts to SPI and power. I'm probably not going to be doing these two buttons today because I've switched to a button panel. So the second layer is basically routing, which hopefully I'll be able to replace this with something a lot smaller at some point. But so it's got the routing, the display. The top layer has the LoRa breakout, the FRAM, and then we also finally have the button panel. And then all of this will go into a 3D printed case. There's some extra, well, we'll go over the other pieces as we go, but obviously we're going to need a lot of header pins and these female connectors, wire, solder, everything else. And you want to be able to at least test for continuity as we're connecting the different pieces and making sure we didn't make any shorts or anything like that. So I'm going to be walking through this a little bit, and so like I said, first we'll start with the base. To solder the rows of female adapters on here, what I do, there's probably a better way, but and remember they go on the inner set of rows here. I will just loosely put them in there, flip this over, and kind of set it on the table, and try to straighten them a little bit, and I'll just put a dot of solder on one pin of each one, and then kind of straighten that after I've already held them in place with a piece of solder. So I'm going to go ahead and do all that now, and the second set of female headers I do the same way. So Okay, so I've got the the female headers in the right place. I got the Arduinos on straight with the programming port pointed toward the lower numbers. So these look pretty good, pretty straight enough. Everything on there is soldered. So the remaining pieces on this base are the real-time clock and a header for that, the I2C and power. That just has 4 pins connected. So you can see where that's going to go. And then on the underside, we have the power board, and we're going to end up at later on having a battery. So, and then I haven't completely finished the design yet, but I think that ultimately the touchscreen will be here. So anyway, so to finish this base, I've got to connect the real-time clock, the power management breakout, and also I need to connect the ground and the positive, that because I do use these in other places. So I'm going to connect those on. You can't see this one, but I'm going to connect that one too. And I probably will go ahead and, I'll go ahead and connect the plus and the ground, positive and the ground, those two that you can see kind of that are under the real-time clock. I'm not going to deal with the button wires just yet. So that's next. So now we have the the base completed as far as we can go right now. So next is the second layer, which has the connection to the display and the routing that routes various pins from the Arduino to things up top. So on this second layer, it's mostly going to be soldering these pins on, and again the routing wiring, which is kind of messy, and I'd rather have a custom board for this, but I'm trying to use, like I said, things you can just buy off Amazon. So this is one way I know how to do it. Yeah, so when we're done with this layer, we'll have all the pins on, we'll have the routing wires, and we'll have the display connection soldered on.
Okay, now we've got the second layer and the base done, and they look pretty good, I think. So now it's time to do the third layer. So this third top layer has the LoRa radio, the FRAM chip. This prototype had some buttons down here, but since we're going to have this in a 3D case now, that we're not going to do that. So all we're going to have on this third layer is the LoRa chip and the FRAM, and also I'll have to mount the antenna connection onto the LoRa chip, and also I'll be attaching the third layer to the second layer. So some wires routing the various pins to SPI connections in power. So when I'm done with this step, I should have something that looks like this. I've got the third layer, the SPI connections, and power and ground just for connecting, the SPI or the FRAM and the LoRa to share what connections they can. Next I'm going to do the board 2 connections to here. So some of these, they get a little tricky. So I'll just be connecting those two, and then finally the breakouts onto the top of there. I don't want to put them on yet because they just kind of be in the way. But I'm going to make some coffee first. last little bit of soldering is going to be making these button panels with this rotary encoder. This is a reset button, and this is going to be the power button. And the way that I connect this power button is a little weird. You might not want to do it that way. If you want to use a different kind of switch, that's up to you. But if you, I'm sticking with these because they will fit in a 3D case just fine. And the button panel is going to end up looking like this. So yeah, also I'm going to have to cut the PCB and drill a hole for the cable to go through. But this is what it ends up looking like. And also I still have to go back and finish the connections. I don't fully connect all of these without at least doing a continuity test first, so that if I have to take this off, it's no problem. Once you've soldered all of them, it's really hard to get these off. That one needs straightened, obviously. So yeah, and also once I have these soldered, I'll be able to plug this into the base and then test the connections before I power it up. Test the connections between the breakout boards and the Arduino with and need to put a battery in and connect the, I didn't connect those yet. On the layer 2, the ground and positive that goes across the board needs to be connected on each side. So I finished soldering that last little bit. The last things, button panel that is, the last thing as far as soldering and things to do before putting it into a case is you need to plug the two. Let me use this one. Plug the base with the button panel together with the second layer here, getting the pins to line up with the headers like that. And you want to tuck the wires a little bit first, so some of these will fit into that little channel pretty well if you kind of bend them down. Then you can route them through here a little bit, make some space. So, and putting a battery in, of course. There's a battery into the real-time clock. So other than that, what you would want to do is use your multimeter to check for continuity between different things. So a good test is the boards. Of course, there shouldn't be a short, so the positive and negative should not have continuity, or else you've got a real problem. But the VIN pins, all of those should be connected to the positive of the board. That's a good check that you can go to do to any of these. So that's good. The SPI pins should be connected, so the clock pin SCK from here should be connected to both of the clock pins on here. Uh-oh. There it is, okay. Same for the output and input, and I've already tested these. I know these are connected okay, so those are some good tests to do. Yeah, so it's putting the battery in, doing a few tests like that, and then you want to finish soldering. I only put one dot on these in case I had to adjust them. So I'm going to go ahead and finish those, trim those down, trim anything down on the bottom that left over from the wires I just put on. So yeah, after that it should be ready to attach a ribbon cable, put it into a case, and plug it in. Yeah, the little pigtail, I'm actually waiting for some of those to come in the mail today, so I don't have one to do right now, but the cable that's going to go with the antenna, you'll have to press that onto these breakouts before you put it into the case. So I'm going to finish that now. Okay, so I just realized, since I had the ribbon on the one I was kind of reference I was working off of, it was covering the I2C pins that I have connecting this display breakout. So I only connected the SPI pin. I need to go back. Right after I soldered that whole thing on, I realized that I had forgotten to connect these I2C pins. So on the other chip, on the other board, I'm going to take this off, put the pins on, put it back, since I only have one dot of solder on that one right now. Yeah, that's why I do that. But so I guess for this one I'm going to have to slide a couple of pins through from this breakout to the next board, and do it that way, because I'm not taking this off. So, oh well.